Greetings everyone, this is non-expert back again with another video where we're trying to solve daily coding problems. The problem that we're solving today is basically rated as a hard problem and it was asked by Stripe. It's a pretty common problem and I've seen it in a lot of interviews. And it's not using any normal approach, it's a lot of mathematics involved in it and just a little bit of presence of mind. So if you've not sort of solved this problem before, you might face a little bit of difficulty, and that's the main reason why this is a hard problem. Another reason why it's a hard problem is primarily because of the constraints. Let's get down to the problem statement. Problem statement describes that given an array of integers, find the first missing positive integer in linear time and constant space. In other words, find the lowest positive integer that does not exist in the array. So the array can contain duplicates and negative numbers as well. For example, the input which is given to us is 3, 4, -1 and 1, and it should return the output as 2. So basically the first missing positive integer. Do note that 0 is not going to be categorized as positive integer, so that's not going to come here. And the value is going to start from 1, 2, 3, 4, and then if 2 is not there, they're just saying that you need to return 2. So the input for another of the examples which is given is that what happens when 1, 2, 0 is given. In which case we need to return 3. So if you get the gist of the problem, it's saying that if you have a list, you just need to compute from to, let's say the length is L, so L plus 1. So your window frame is going to be from 1 to L plus 1, or L if you include L. Cool. So the constraints which I was talking about, so this is actually pretty easy to solve if you use a visited hash map or dictionary, right? It's pretty easy, you don't have to do much there. All you have to do is maintain a visited dictionary and just say that if something has been visited, good. And if it's not been visited, when you do the second iteration, you can just say that, hey, I've not visited this before, just return the value. Unfortunately, we cannot do that because we need to do this in constant space. We'll put another constraint here. Basically, we cannot make any other temporary arrays as well. We cannot make dictionaries, we cannot make arrays, we can make a few variables, but that's the only space that we can use. And we need to do this in linear time, so basically in O of n, which is a little bit tricky, but not impossible. One of the hints which is given to us is that we can modify the input array in place, and we will definitely be leveraging that. Alright, cool. So fortunately we were able to find this problem on LeetCode. Let's go to the problem. And you can see over here it's the same exact problem. The name of the problem is first missing positive. It states that given an unsorted integer array, find the smallest missing positive integer. It's exactly the same. You can see these two sample examples are exactly the same, and they have the same conditions. Alright, cool. So before we start with the implementation, we need to understand for a fact that we will be changing the array in place. But before we do that, there are basically two conditions which we need to follow. So again, let's just, before we start off with our implementation, let's just write a base condition. Let's just return 1 if nums is not there. Actually, I'm not sure whether this would actually be a condition because nums needs to contain something. But just for our condition, we're just going to start off with this. So the first two conditions that we take care of. The first condition is that we don't really care about elements or element values which are not in our frame. So our frame needs to reside from 1 to n plus 1, right? So anything which is like, let's say 0 and less than 0 or less than 1, basically if x is less than 1, we need to discard that value out, right? And again, if you remember, we are going to be putting a few operations directly in our array elements. So we'll be changing the array in place. Again, it's a little bit of maths, and I'll try to explain it as I go. But first, we need to break this down. And since we're discarding elements, we won't really be, removing the elements from the list. Rather, what we'll be doing is we'll be updating them with 0. So let's just do a quick for loop where we say from norms, and actually we're going to be leveraging length a little bit. So let's just make a new variable and call it n, which is basically going to denote our length. And what we're going to say is we're going to say that if norms I is less than equal to 0, or if norms I is greater than n, we basically want to update this with 0, right? So all the elements, let's take this example, for instance. We'll be taking this example, we'll be moving forward with this, so let's just comment it over here. So what we want in the output right now is basically this. Cool. And again, we're just discarding all the elements which are sort of not required for us, right? Now comes the mathematical part. What we're going to do is we are going to basically, or in other words, let's just say that we're going to be leveraging the fact that we have, we'll be using the indexes as the hash map itself. Let's get on to the implementation. Actually, it'll be easier for me to explain it when we sort of do it. So what we're going to do is we're going to do another iteration. And the way we're sort of going to update our nums is basically going to be based on whatever value is residing inside our ith value, right? And basically we'll be just doing modulus of n, and we'll just be simply adding n to it. It seems a little weird right now, but you'll understand what I'm trying to do in a while. Alright, cool. So all we're doing is, we're just implementing, or sort of we're just updating the array in place. But while we're updating the array in place, we are also making sure that while we're updation, we're not losing the entire essence of that particular array. And you'll understand the essence of the array when we do another for loop. So if I do another for loop and I do for I in range of n, the only thing that I sort of need to check is basically what happens if nums of I is sort of divided by n, or actually use Python over here. So what happens if if I use divide by n if the value is equal to 0, in which case I just need to return I. Otherwise I just need to return n because I have not encountered any other value. That's it. That should do it for us. So again, all we're doing is we are just updating the array in place. I'll put a few print statements so that's easier for everybody else to see. Let's just write quick print norms, and let's just, for the sake of clarity, let's skip it. All right, cool. Let's just try running this. Hopefully it should run. Let's just go through it. Hopefully I'm not facing any problems. Alright, cool. So as you can see here, the very first test case which is running is 1, 2, 0. And it's pretty simple, right? There's not much which is happening here since we didn't need to discard any of the elements. This entire operation just returned the same array which we had before. The only thing which we sort of need to take care of now is that when we're updating the array in place, we are just saying that, hey, we need to look for the element which is modulus of n. So basically when we go over here, when we come to 1, which is the first, not the first index, it's the second index, because starting from 0, 1, 2, what's going to happen is we're going to say that, hey, I have 1 over here, modularize it, sort of get the remainder out when we divide by n, which is also going to be equal to 1 in our case, and basically add it with n, right? And when we do the addition to n, we're not really losing particular value, because as you can see here, all you have to do is you can you know, you can just divide by um, divide by 3, which is the length. If it's divisible by 3, it means that that value has never been encountered, right? Again, pretty simple. I think one mistake which I've sort of made, which I can see right now, is that I am saying that for I in range, I need to start from the first to the nth value, right? Um, cool, seems pretty okay-ish for now. Let's just try submitting it, and you'll see if I've missed out on any edge case as such. Again, this is like a little bit mathematical, so if you have a pen and a paper, it's easier for you to jot down what exactly is happening. But all we're trying to do is, when we're doing the addition over here, the only reason why we're doing the addition and not just updating it by some value just like that is just because of this reason, that when we do the addition, they can, first of all, they can be multiple duplicates as well. And the second thing which we sort of need to take care of is that n needs to be equal to 0. If it's equal to 0, then we've found something. Okay, cool. So unfortunately, this thing is not running right now. Let me just do a quick check on why it's not. And I see what's happening here. Um, right, so as I mentioned before, we need to go from 1 to n plus 1, where n plus 1 is not inclusive, it's excluded, but we need to consider n as well. So as you know, when we start with this from uh, 0 to n minus 1, we say that our length is n, but the index which we're starting from is so the way to sort of handle this thing is basically if we do a quick append, right? And if we do an append of 0, what's basically happening is at the very end of the index, we're just saying that, hey, n also needs to be there. So if I say 1 comma 2 comma 3, right, 3 needs to be there. Or if I do 1 comma, so take this example, right? If I do 1 comma 2 comma 0, I need to make sure that 3 occurs. But if 1 comma 2 comma 3 is already there, then we need to take care of that as well. All right, cool. Let's just try to run this once, and hopefully we'll be able to note that we're getting the correct response. Okay, and we are getting the correct response. Let's try running it again. And awesome. All right, cool. So finally this worked. Faced a little bit of difficulty there, but just had to go through it one more time. It's better to just jot down whatever basis that you have, whatever you understand on how you're sort of breaking down the problem. So once we had broken down the problem, it was easier for us to debug, because this particular comment helped us debug the entire solution out as well. All right, cool. So we're done for this particular problem. Thank you again so much for watching this video. And if you really do like this series, please do give a like and subscribe. And if you want me to explain something, do leave a comment out and I'll try to respond to it. And also, thank you so much for watching this video. You're awesome. We all know it. And have a great day.